Hello students, let's continue with the problems on trigonometric identities. So the eighth question is sin A plus cosecant A the whole square, cos A plus secant A the whole square is equal to 7 plus tan square A plus cot square A. Okay. So as usual, let's take our LHS. Okay. Let's take LHS. Here LHS is sin A plus cosecant A the whole square plus cos A plus secant A the whole square. Okay. Now, as usual, we have to check if there is any identity. As you can see, there is no identity. There is no trigonometric identity here. Okay. Therefore, we have to convert everything into sine and cos. Or you can also observe that if you observe here, it is in the form of a plus b whole square, and this is also in the form of a plus b whole square. So you can also convert it into sine and cos, and you can solve it. That is also correct. Okay. But let's use a plus b whole square formula, which makes the problem bit easier. Okay, both the methods are actually correct. Okay, usually what we used to do was, when there was no trigonometric identity, we were converting into sine and cos, then we were taking LCM and simplifying. This is what we were doing. But here, as you can see, there is a plus b whole square. Let's use a plus b whole square itself, because the problem will be solved much easier in this way. Okay. So if I use a plus b whole square, a is sine A and b is cosecant A. So a square, that is sine square A, plus b square, that is cosecant square A, plus 2ab, 2 sine A into cosecant A. Same thing for the other one, cos A plus secant A the whole square. So cos is the a value and b value is secant A. So a plus b whole square is a square plus b square plus 2ab. Okay, we have used the formula. Okay, now in the next step, what we'll do is sine square as it is plus cosecant square as it is plus 2 sine A. Remember, cosecant A can also be written as 1 by sine A, isn't it? The reciprocal relation. So again, cos square A plus secant square A plus 2 cos A. Secant A will be 1 by cos A. Okay. Now, as you can see, sine and sine gets cancelled. Cos and cos gets cancelled. So what is left out? Sine square A plus cosecant square A plus 2 into 1. 2 into 1 is 2 plus cos square A plus secant square A plus 2 into 1 is 2. Now let's add it. This 2 and this 2 gives you what? 2 plus 2 is 4. Therefore 2 plus 2 is 4 plus sine square A. Let me write cos square A first, then the remaining, that is cosecant square A and secant square A. Okay, we know that sine square A plus cos square A is what? 1, according to the trigonometric identity. So 4 plus 1 plus cosecant square A plus secant square A. Now 4 plus 1 is 5. 5 plus cosecant square A plus secant square A. But you have not got the final answer. The final answer, if you observe, that is the RHS, is in terms of tan and cot. So can I get tan and cot using this cosecant and secant? Yes. Actually, if you remember, 1 plus tan square A is actually equal to secant square A, isn't it? And 1 plus cot square A is actually equal to cosecant square A. Therefore, if you observe, in place of secant square A, we can write it as 1 plus tan square A, and in place of cosecant square A, we can write it as 1 plus cot square A. So 5 plus cosecant square A can be written as 1 plus cot square A plus secant square A can be written as 1 plus tan square A. Now if you add all the digits, 5 plus 1 is 7 plus tan square A plus cot square A. which is nothing but our RHS. Okay. So, which is nothing but our RHS. Okay. It's very simple. We have used a plus b whole square and we have solved it. So you can also solve it by converting into sine and cos. That is, so usually that is what we were doing, isn't it? The LHS was sine a plus cosecant a the whole square plus cos a plus secant a the whole square. Now there is no trigonometric identity. If there is no trigonometric identity, we'll convert into sine and cos. So cosecant can be written as 1 by sine a the whole square, and this cos a plus secant a can be written as 1 by cos a the whole square. Here if you take LCM and solve it, definitely you will get back the same thing. Okay, you can try it, take it as a task and just try it. Okay, take LCM and use the trigonometric identity, you will get the answer, but it is bit lengthy. Okay, that is why we have used this method. Okay, let's get into the next one. So again, let's take the LHS, and they have given us the hint that we have to simplify LHS and RHS. Okay, now let's take the LHS, which is cosecant A minus sine A, okay, into secant A minus cos A. Now what is cosecant A? Cosecant A, see there is no identity, so we are going to convert everything into sine and cos. Cosecant A is 1 by sine A minus sine A. Secant A is 1 by cos A minus cos A. Now we must take LCM. The sine A can be written as sine A by 1, cos A can be written as cos A by 1. So multiply sine A into 1 is sine A. Then crisscross, 1 into 1 is 1, minus sine A into sine A is sine square A, isn't it? Now 1 into cos A, or cos A into 1 is cos A, crisscross, 1 into 1 is 1, cos A into cos A is cos square A. Now if you observe, there is an identity. 1 minus sine square A is what? Cos square A divided by sine A into 1 minus cos square is sine square A divided by cos A. If you observe, cos A 1 times gets cancelled, sine A 1 times get cancelled. Therefore, in the numerator, still 1 cos A and 1 sine A is left out, isn't it? But from here, you cannot get anything. You cannot proceed further. So therefore, we got to know that we have to simplify the RHS also. Okay, in the LHS, the answer that I got in LHS, you cannot proceed further. Cos A into sine A, what can we do? We can't do anything. So let's take the RHS. Okay, what is our RHS? 1 by tan A plus cot A. Now, is there any identity for tan A plus cot A? No, there is no identity. If there is no identity, what should we do? Convert everything to sine and cos. So sine A by cos A plus cot A can be written as cos A by sine A. After conversion, we have to take LCM. So let's take the LCM. 1 by, multiply the denominator. Cos A into sine A is cos A sine A. Then crisscross. Sine A into sine A is sine square A. Cos A into cos A is cos square A. Okay. Now, if you observe carefully, we have got an identity here, isn't it? So 1 by sine square A plus cos square A is what? 1 divided by cos A sine A. Now we have to reciprocal the denominator, isn't it? So 1 into, if you reciprocal, it will become cos A sine A divided by 1. So 1 into anything is same thing, isn't it? So therefore, you can write the final answer as cos A sine A. If you observe, when you simplified LHS, you got the answer as cos A sine A. When you simplified the RHS also, you got the answer as cos A sine A. Therefore, from 1 and 2, we can tell that LHS is equal to RHS. Okay, very simple. We are following the same procedure in all the problems. That is, the first step is to check if there is any identity. If there is identity, we're going to use it. If it is not there, then we're going to convert everything into sine and cos. After conversion, we must take LCM. Once we take LCM, definitely we'll get an identity, that is trigonometric identity or algebraic identity. If you use that, easily you'll get the answer. So let's get into the next question. If you observe the next question, we must prove that 1 plus tan square a divided by 1 plus tan cot square a is equal to 1 minus tan a by 1 minus cot a the whole square is equal to tan square a. Okay, we have to prove all these three are equal. What we'll do is we'll prove this 1 plus tan square a by 1 plus cot square a is equal to this. Similarly, we'll prove the second one is also equal to this. Therefore, all three will become equal. That's what we are going to do. Okay, so let's start with, okay, we cannot say LHS here because there are three things. So let's consider the first one, that is 1 plus tan square a divided by 1 plus cot square a. We are trying to prove it is equal to tan square a. That's what we are trying to prove. Okay. Now, if you observe, there is an identity, isn't it? As you can see, there is an identity. 1 plus tan square a can be written as what? Secant square a. And 1 plus cot square a can be written as what? Cosecant square a. Now, let's reciprocal it. Let's use reciprocal relation. Secant square a can be written as 1 by cos square a. And cosecant square a can be written as 1 by sine square a, isn't it? Now let's reciprocal it. That is 1 by cos square a as it is into the reverse sine square a by 1. So 1 into sine square a is sine square a. 1 into cos square a into 1 is cos square a. So what is sine square a by cos square a? Sine square a by cos square a is tan square a. So we have got it. Okay. Let's take it. So what we have proved is, we have proved that 1 plus tan square a by 1 plus cot square a is equal to tan square a. Let's take this as equation 1. Okay. Now, again consider, let's consider this, that is okay, 1 minus tan a the whole 1 minus tan a by 1 minus cot a the whole square. Okay, let's consider this. Again, we are trying to prove that it is equal to tan square a. That's what we are trying to do. So as you can see, 1 minus tan a, there is no identity. 1 minus cot a, there is no identity. So as you know, we have to convert it into sine and cos. So 1 minus tan a can be written as sine a by cos a. Okay. Divided by 1 minus cot a can be written as cos a by sine a. Okay. And remember, there is a power outside, that is the square outside. So let me put the square outside. Okay. In the next step, obviously after conversion, we have to take the LCM. This 1 can be written as 1 by 1 and this 1 can also be written as 1 by 1. So take the LCM. 1 into cos a, multiply the denominator. 1 into cos a is cos a, then crisscross. Again 1 into cos a is cos a, minus 1 into sin a is sin a. Okay. Same thing for the denominator. 1 into sin a is sin a, then crisscross. We will get it as sin a minus cos a. So the whole square. Okay. Let me continue here. So in the next step, it becomes, let's reciprocal it. Okay. Cos a minus sin a divided by cos a. The denominator, if you reciprocal it, okay, it will become sin a by sin a minus cos a. Okay. Now, if you observe, this numerator and this denominator actually are same, isn't it? But the only thing is they are like reversed. The denominator is reversed. Okay. In the numerator, it is cos a minus sin a, but here it is sin a minus cos a. So what we can do is, we'll take minus common, and remember there is a square outside, so let's put that. So in the next step, cos a minus, or let me take minus common in the numerator itself. So it will become, if I take minus common here, okay, it becomes minus cos a plus sin a, isn't it? If I take minus common, okay, multiply back, you get back the same thing. Minus into minus plus, minus into plus is minus. Okay. So in another word, if I take minus as common, then I can write it in the reverse order. That is, it will become sin a minus cos a. Okay. Divided by cos a into sin a. And the denominator here, it is sin a minus cos a. Okay. And it is whole square. I'm sorry. It is whole square. As you can see, sin A minus cos A, sin A minus cos A gets cancelled. So you're left with minus 1 by cos A into sin A by 1 the whole square. So let's multiply. Minus 1 into sin A is minus sin A by cos A the whole square. What is sin A by cos A? It is tan. So minus tan A the whole square. Minus tan A the whole square is what? Plus tan A the whole square, that is nothing but tan square A. Let's take it as equation 2. If you observe, 1 plus tan square A by 1 plus cot square A is also equal to tan square A, and this is also equal to tan square A. So from 1 and 2, you can tell all the three are equal. From 1 and 2, we can conclude, from 1 and 2, we can conclude that 1 plus tan square A divided by 1 plus cot square A, that will be equal to 1 minus tan A, 1 minus tan A by 1 minus cot A the whole square, that is equal to tan square A. Okay, so this is how we do it. See, we are if you observe, we are using the same logic throughout all the problems. Okay, that is, if there is a trigonometric identity, we'll use it. If there is no trigonometric identity, we'll convert it into sine and cos. Then we'll take LCM and simplify it. And if you remember in the previous video, we had left this question. Okay, so let's solve it now. See, if you observe, this question is a bit different compared to all other questions. In all other questions, if you observe, whenever you add a fraction kind of a thing, like this fraction kind of a thing, you had only 2 terms. Okay, but here you got 3 terms. Take any problem. As you can see, even here, there are only 2 terms in the numerator, 2 terms in the denominator. Okay. Any equation in terms of fraction, see, it's like P by Q form. See, there are only 2 terms. Any question for that matter. Let's take the first question also. Okay, you observe any question, it was either there was only one thing, that is only the numerator, or if you had numerator and denominator, then there were only 2 terms. Observe this question, 1 plus secant A by secant A, there were only 2 terms, isn't it? Even this question. And even this question, there were only 2 terms, but this question is a bit different. Okay, there are 3 terms actually here. You can actually directly solve this, but let's make it a bit easy. Okay, and if you observe, they have given you a question saying that prove that cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equal to cosecant A plus cot A using the identity cosecant square A is equal to 1 plus cot square A. Okay, so we have to use this identity. Now remember, whenever you see this type of question, okay, now this is a bit different question. Okay, completely different. Here we are not going to use the 4 rules which we had learned. Here we are going to use a different technique. Okay, so what we are going to do is we are going to convert the numerator and denominator in terms of tan and secant or cosecant and cot. Okay, so the numerator and denominator will be converted in terms of this or this, depending on the question. If you observe the question now, in the question it is, what is the RHS? My RHS is cosecant and cot. Therefore, I'm going to convert the numerator and denominator in terms of cosecant and cot. Okay, if the RHS was tan and secant, then we would have converted the numerator and denominator in terms of tan and secant. Okay, this is how we do it. It depends on the question. Okay, sometimes they might give you like this also. For example, let's say 1 plus cos A divided by sin A. Okay, instead of giving like this, they can give you like this. Okay, now if you observe, if you split the denominator, it becomes 1 by sin A cos A by sin A, isn't it? What is 1 by sin A? Cosecant A. What is cos A by sin A? Cot A. So we got to know that. See, if they give like this, then it's a bit confused, right? You just simplify the RHS, you get cosecant A plus cot A, which means the numerator and the denominator should be converted in terms of cosecant A and cot A. Okay, so it's a very simple logic. Very simple. See, depending on the question, see here the RHS is cosecant A and cot A. Therefore, the numerator and the denominator the numerator and the denominator will be converted in terms of cosecant and cot. How do we convert it? If you want to convert into cosecant and cot, divide by sine. Okay, we have to divide by sine. If it is in terms of tan and secant, then we have to divide by cos A. Okay, if you want to convert in terms of tan and secant, then we have to divide throughout by cos. Okay, so here we have to convert into cosecant and cot. Therefore, here we have to divide by sine. Okay, divide. Let's take the LHS. What's the LHS? Cos A minus sine A plus 1 divided by cos A plus sine A minus 1. Divide both numerator and denominator. Both numerator and denominator by what? By sine A. Therefore, see, both numerator and denominator we have to divide by sine A, which means for each term we have to divide by sine. Okay, so let's do that. So the first term is cos A divided, so it will become cos A by sine A minus sine A by sine A plus 1 by sine A. This is the numerator. Okay, now let's divide it for the denominator. For each term we must divide it. Okay, again cos A by sine A plus sine A by sine A minus 1 by sine A. Now let's use the quotient relation. If you remember, what does cos A by sine A? Cos A by sine A is cot A minus sine A by sine A is 1 plus 1 by sine A is cosecant A divided by cos A by sine A is cot A plus sine A by sine A is 1 minus 1 by sine A is cosecant A. Okay, from here we are not going to do anything to the denominator. Okay, we'll keep it as it is. Let's not worry about the denominator. Okay, let's keep it as it is. In the numerator, what I'm going to do is I'm going to get that 1 to the end. Okay, I will rearrange it. Cot A plus cosecant A. Then I'll write it as minus 1. I've just rearranged it. Okay, let's not worry about the denominator. Let's keep it as it is. Okay, let's keep it as it is. Cot A plus 1 minus cosecant A. Okay, we are not gonna worry about the denominator. Okay, now here if you observe in the question itself, they had told you use the identity cosecant square A is equal to cot square A plus 1. So get this cot square to the other side, it becomes cosecant square A minus cot square A is equal to 1. Okay, which means in place of 1 we can write it as cosecant square A minus cot square A. Okay, that's what we are going to do in the next step. Okay, let me draw a line. So cot A as it is. Okay, or we can also write it the other way. Instead of writing cot A plus cosecant A, let's write it as cosecant A plus cot A. Okay, minus, in place of this 1, okay, in place of 1, let me write it as cosecant square A minus cot square A. Okay, in place of 1, that's what we are doing. Okay, because cosecant square A minus cot square A is equal to what? 1. Okay, so minus as it is, in place of 1 we have written it, okay, within the bracket, because there are two terms. We are not going to do anything to the denominator. The denominator will remain as it is, cot A plus 1 minus cosecant A. So cosecant A plus cot A. Okay, let's put a bracket. Let's consider this to be one term minus. Now, if you observe, this is in the term of, this is in terms of A square minus B square. So I can write it as A plus B into A minus B. Okay, divided by cot A plus 1 minus cosecant A. Now, if you observe, there are two terms on the whole. Okay, consider this to be one term. and this is another term, because this and this are in product, therefore they are considered to be one term, isn't it? So this is one term and this is another term. In these two terms, if you observe, I can take cosecant A plus cot A as common, isn't it? So if you observe, here also you got cosecant A plus cot A, here also you got cosecant A plus cot A. So we can take that as common. So what is left out? 1 minus, we took this as common. What is left out? The other bracket. In what is in the other bracket? Cosecant A minus cot A. Okay. So divided by the denominator as it is, cot A plus 1 minus cosecant A. Okay. So cosecant A plus cot A as it is. Now if you simplify this bracket, 1 minus into cosecant A minus cosecant A, minus into minus plus cot A. Okay, divided by cot A plus 1 minus cosecant A. Now if you observe here, cot A plus 1 minus cosecant A, this thing and this thing gets cancelled, because you got same things, isn't it? Here you got cot A plus 1, here also you got cot A plus 1 minus cosecant A. Both are same, isn't it? Therefore they get cancelled. That is why we don't do anything to the denominator, we keep it as it is. Okay, and therefore you're left with cosecant A plus cot A, which is our RHS. It's very simple. Whenever you see such kind of question, whenever you got three terms like this, okay, there is only a few types of problems like this. Okay, now in this type of problem, remember, you're going to convert the numerator and denominator according to the question. Here in the question, the RHS is cosecant and cot, therefore you're going to convert into cosecant and cot. If it was tan and secant, then you would have converted into tan and secant. Now how do you convert it into cosecant and cot? To convert it into cosecant and cot, you have to divide by sign for both numerator and denominator. Once you divide both numerator and denominator, it will be converted in terms of cosecant and cot. Don't do anything to the denominator, keep it as it is. In the numerator, get this one to the end. Okay, like this. What we have done, we have got it to the end. And for this one, use the identity, that is cosecant square A minus cot square A. If you have converted into tan and secant, there you will use secant square A minus tan square A. That is the identity that you will be using there. Okay, here in place of 1, you will write it as cosecant square A minus cot square A. Now, after writing it as cosecant square A minus cot square A, use A square minus B square formula. Okay, so it can be written as A plus B into A minus B. Then when you write A plus B into A minus B, definitely you will get common. You take out the common thing, and the left out thing in the numerator and the denominator gets cancelled. If you observe, after taking common, this is the common that we took, and the left out thing is written in another bracket. That and the denominator gets cancelled, and this will be your final answer. Okay, so this is how we solve this kind of problems. Okay, in your textbook there is also an example problem similar to this. You can try it out. Okay, so with this we have completed with the trigonometry chapter. I hope you have understood all the concepts. Let's start with another chapter in the next video. Thank you, students.